Temblor has just published a new analysis of the interaction of the magnitude 7.8 and magnitude 7.5 Turkish earthquakes that struck in February. And we've used the latest source models from the USGS and the latest seismic data from AFAD in Turkey. And we found, as we did before, that the magnitude 7.8 rupture brings the site of the subsequent magnitude 7.5 significantly closer to failure, and that earthquake would rupture 9 hours later. But however, we find that the 7.8 also inhibits a large part of the magnitude 7.5 rupture from failing, where it reduces the stress. But somehow, once that magnitude 7.5 earthquake got going, it was able to crash through the portion of the fault that had been inhibited by the magnitude 7.8. And when we combine the stresses cast by both earthquakes, what we see is that the surrounding faults are bathed in aftershocks well off the rupture surface. The most prominent of these are along the East Anatolian Fault, extending to the northeast for over 100 kilometers. We also see aftershocks extending to the southwest in the Cypriot Arc Fault, and perhaps along the northern tip of the Dead Sea Fault in the south as well. Now, we've also explored what this great earthquake sequence might mean for California. And it's important to realize that these two fault systems are remarkably similar. What happens in Turkey always matters for California. The North Anatolian Fault and the San Andreas are essentially sisters. But what is less well known is that the East Anatolian Fault very closely resembles 4 or 5 major fault systems in California that we now can see are also capable of magnitude 7.8 earthquakes. And the Surgu-Kardok Fault, on which the magnitude 7.5 occurred, is a dead ringer for the Garlock Fault, which itself was strongly stressed by the 2019 Ridgecrest earthquake. So read the paper to learn more.